Okay, so this is my solution for Wednesday of week 1. And this problem was about a speeder on a highway and a highway patrol officer. So the idea is that the speeder was originally traveling a very fast rate of speed and passed the officer who was driving with traffic. So let's call the moment of 0 time being when she realizes she's passing the officer, and so she, instead of continuing on her fast path, begins to slow down. Meanwhile, the officer, who was going at a low rate of speed, sees the speeder whiz by and begins to speed up. Now, the trick to this problem, and this is position, the trick to this problem is that the officer catches the speeder when the position of the officer equals the position of the driver. Not, as we said in class, when the speed equals the speed. In fact, that happens somewhere here in the middle. Okay, so what we know is that the initial speed of the driver is 80 miles per hour, and the initial speed of the officer is, let's see, 60 miles per hour, and the acceleration of the officer is 3 miles per hour per second, and the acceleration of the driver is equal to 1 mile per hour per second. Now, because I'm using positive values for the speed, I know that the acceleration of the driver can't also be positive. It has to be in the other direction. That's what leads to the slowing down. So I know just from the statement of the problem that it has to be a negative acceleration. Okay, so you can do this problem in 2 steps, but the other way to do this problem is to think about an equation that has the things you want, but doesn't have the things that you don't want. So let's see. What I don't know is their final speed. So I want to pick the kinematic equation that doesn't have the final speed. And I think it's this one. The x is x naught plus v naught t plus 1/2 a t squared. And so if I write this down for the driver, and let's call the initial position 0, so it's 0 plus 80 miles per hour times time plus 1/2 -1 miles per hour per second times t squared, and x of the officer is his initial speed, or her, okay. So I'm going to use my criteria for catching and set these two equal, and so I get 80 miles per hour times time plus 1/2 -1 miles per hour per second t squared equals 60 miles per hour times time plus 1/2 3 miles per hour per second t squared. Okay, so I'm going to divide through by t, and I have only 2 terms that still have t in it at all, so I will combine them. And so I'll take the 80 minus 60 over here, 80 minus 60, and that's 20 miles per hour. And let's see, I'll add the 1 to the other side, so that's 1/2 4 miles per hour per second is t. And so I'll take the 20 times 2 is 40 divided by 4 is 10, and the miles per hour cancel, so sure enough, 10 seconds is the time. And that's part A. Okay, so what about part B? Well, part B is asking the speed. And so now I can use for part B the velocity final velocity is just the initial velocity plus the acceleration times time. And now the time is going to be 10 seconds. So I get that V for the officer is equal to 80 plus 3 times 10. Oh, no. Let's see. The officer was going 60 miles an hour. Sorry about that. 60 miles an hour. So 60, there we go, plus 3 times 10 is 30, so that's 90 miles per hour. And the driver was going 80 minus 1 times 10, so I was still going a pretty healthy 70 miles per hour. And that's the end.